Thank you, John and Paolo, for the opportunity to provide a brief presentation. As Paolo mentioned, I did change the subject, and thank you for being flexible on the change of subject. If any of you are disappointed and you want to hear about some innovations in GPS monitoring, you're welcome to come down to our table downstairs afterwards. I wanted to talk about big data. It's a term we've heard a lot actually in the news the last couple of years. I was just reading about a fundraise recently for a company called Domo. They raised as an initial fundraising effort $500 million for this idea of big data. So there's been a lot of attention lately, and we've seen advertisements about the Watson supercomputer. It's all the same idea, and we'll talk about how it relates to the geotechnical instrumentation market, because big data is coming to this market. In fact, I suggest it's actually here, whether we like it or not. So let's go back in time to set some historical context here. This is a sketch of the Library of Alexandria, built around 300 BC. It was really quite a unique idea to create a repository for knowledge. And over the coming centuries after it was built, it's believed that it got to the point where it actually encapsulated all of human knowledge. So somewhere between 500,000 to 700,000 scrolls of information. Unfortunately, like all good things, it came to an end, and I think around 200 or 300 AD, so just a short time after it was built, it went through a series of destructions and eventually was lost entirely. The entire library was destroyed, and that body of knowledge as well disappeared. Well, it was back. Back in the 90s, I had the opportunity to actually work on the new Library of Alexandria. It's really a fascinating project, working in Egypt for about a month. They were doing pile load tests, but mostly tension tests, because as you can see from the illustration of the completed library, which was finished in 2002, it's built very close to the sea. So one of the big challenges was the worry that the whole structure would float up over time. So most of the pile tests were tension tests, and I had the opportunity to run the pile testing program there. Fascinating trip. I'd love to go back, but I'd probably have to get like a Canadian or a UK visa. Otherwise, I don't think I'd last very long. You can see on the picture on the right how the library has changed, though, from the ancient construction. You can see mostly it's computer terminals. What happened after the library was completed is they received, just like the original library, manuscripts, documents from all over the world, but they've all been digitized now, and so you can go and search through the archives and likewise have access to broader information across the internet as well. So just to put it in some context of how much information has changed, the first number, 200 megabytes, that's experts' opinion about the capacity of our brain. When I first saw that number, I didn't believe it, actually. I would say my brain is maybe like 2 megabytes. And then over time, I think I'm losing about a megabyte a year. A byte, of course, for those of you who aren't familiar with computer terms, is basically one character. So my name, Alex A., that's 6 bytes, 6 characters. So that gives you an idea about how much information this is. The 20 gigabytes, the second number, that's considered the amount of information that was stored in the Library of Alexandria. And can you take a guess what the last number is? 1.5 zettabytes. That's considered the amount of publicly available information that we have today. It's really a staggering number. In fact, there's only one more prefix in the metric system, which is iota, and it's considered that, or believed in the next few years, we're actually going to have to make some new prefixes to deal with the fact that there's more and more information every year. Just to give you an idea of the size here, so I saw this number, or this piece of information on the internet, that if we were to take 1.5 zettabytes and put it on a standard like 700 megabyte CD with no case, it would be 5 stacks of CDs between the Earth and the Moon. It's hard to believe. Now, if we turn those into like a DVD, we'd still have over a stack of DVDs from the Earth to the Moon. It's hard to believe. I actually didn't believe that, so I actually calculated it out, and it actually came out to 6 stacks. A CD is 47 thousandths thick. And if you calculate it out, it came out to about 6 stacks of CDs. All right, so how does this relate to geotechnical instrumentation and monitoring? Well, here's an illustration of from our software user's guide about how data can be integrated. And again, we're not the only company doing this, but it illustrates all the different sources of data that are available now, different types of devices, GPS, INSAR, radar, robotic total stations, data loggers. What we're seeing more in recent years is the integration of data from publicly available sources like the seismic databases, the NOAA weather databases, the USGS databases. Par talked earlier about the buoy system that's deployed across the world. All that information is actually publicly available and can be integrated to monitoring systems now. So one of the first challenges we've seen, and again, this is a picture from our software, but numerous vendors now have figured out how to integrate all this data. And we're seeing a lot of progress in recent years with this idea of now bringing data into a single dashboard, a single view, where you can locate and find all the different sources of information that you have available. So in this view here, we see a graphical depiction of a project. All these dots that you see, all these little dots refer to different types of instrumentation that are available in your project. And again, we see this from numerous vendors now, this ability to bring all these different sources of data together and help put it into a single context that provides for easier access and easier understanding of the data as it relates to your project. The second challenge we're seeing, though, is now what to do with it all. And I was at a client site a couple of weeks ago, just to put this in perspective about how we've seen this change in our industry. Just a couple of years ago, this client was using Microsoft Excel, and they had a series of worksheets to aggregate data from some of the monitoring on the site. Well, a couple of years ago, we started a project with them to integrate all that data. Their database was 17 gigabytes, and I couldn't believe it. I mean, I looked at the types of data they had in there, about 110 million data points, documents, drawings, radar imagery. Is really astounding for a project that really just had a few megabytes of information just 2 years ago. Now they have 17 gigabytes on this one project. So what to do about it all? Well, sometimes, as the illustration describes, you know, it's hard to comprehend it. And for those of you who don't speak English as your first language, snookered is getting drunk. Not that getting drunk in the context of risk management is a good idea, but it does happen. I've seen it. So this is the next development we're seeing in our industry. We've figured out how to bring data together. In the coming years, we're going to see much more change as it relates to understanding what this data means. So just to summarize, information we see is being created really at an unbelievable pace. Some experts say we're doubling information every year. And keep in mind, this 1.5 zettabytes, that's publicly available information. The suggestion is that actually privately created information is about the same every year. So 1.5 zettabytes of information that we don't have access to is actually being created every year as well. It's hard to comprehend. So we've seen in recent years numerous vendors create systems to integrate that data. The next area of development, hopefully in the future, we'll have the opportunity to talk a little bit more about this. But we're seeing a lot of interest and effort being put into tools, methodologies to now analyze and really get a lot of value out of all this data. Thank you for your time.